Hello, and welcome to Answer Everywhere. Today, we're taking a look at the programming language Zig. Now, I know Zig is cool and people are into it, but I don't know anything about it. And so the repo for Zig itself is written in Zig primarily, and I've never seen Zig. I've never seen the code. I don't really know anything about what its features are. And so I'm really just going to be winging it, trying to figure out what they're up to. They describe it as general purpose. I've heard people talk about it as maybe as a sort of replacement for C or C++. I think it's supposed to be able to do uh, like system programming, general purpose programming language and toolchain for maintaining robust, optimal, and reusable software. No hidden control flow, no hidden memory allocations. So I'm not sure, but I'm guessing this may mean that you have direct memory management. It has no preprocessor and no macros. So it's, I guess, limited in expressivity compared to something like C++ or C. And then a fresh approach to metaprogramming based on compile time code execution and lazy evaluation. Call any function at compile time. Manipulate types as values without runtime overhead. And comp time emulates the target architecture. Okay, and then we'll see, we might see how this works. Some of that might be over here. Although I'm not seeing off the top of my head anything that looks much like metaprogramming. And then we have some stuff about a zero dependency drop-in C++ compiler that supports cross-compilation out of the box. You can leverage Zig build to create consistent development environment across all platforms. And you can add a Zig compilation unit to C++ projects. Should we look at code examples? I guess so. So interoperability, memory leak detection. Let's look at memory leak detection. Using standard heap general purpose allocator, you can track double freeze and memory leaks. So we're importing standard. You're getting this allocator. This is like a constructor. We're deferring the cleanup, and I guess similar to Go. And then we're getting an allocator, I guess, from the thing that we created here. I don't know if this is a factory or what exactly is going on here. But then we try to create a pointer from the allocator, I guess of type U32, and then we silence it. And then it can detect that we forgot to free the pointer. Okay, fine. And it's trying to be simple. I tend to think of with these languages like with Go, etc. The complexity really never goes away. And so when I see somebody, my personal bias is when I see somebody trying to make a simple language or a simple project, often that means the complexity is pushed toward the developer. And the tool, which is the easier thing to kind of handle the complexity because it's written down and people are working on it. If the tool really tries to be simple, then often you push the complexity onto the user, where it's much harder to handle the complexity. So I don't know if that's true of Zig, but that's one kind of, I guess, bias or point of view that I have when I see people try to extol the virtues of simplifying things. All right, so here we have the things that look interesting are source and lib. Stage one may be about perhaps bootstrapping compilation stuff, and then we have tests and tools. CMake, presumably just CMake support, or maybe this is the build file for, this is like stuff to find and install CMake, I guess. Or maybe this is just the CMake file to install Zig. All right, so I'm guessing source and lang are the place to be. I will open up stage 1 just to see if it looks like something amazing. I see WebAssembly stuff and a Zig header. I don't know if this is like the Zig header. A bunch of if defs. This is what? This is C. Okay, that was lost on me when I was looking at it. So this is some C code to, I guess, start bootstrapping the ability to write the rest of Zig in Zig is what I'm going to suppose. So in source we have things like sema, which is perhaps semaphores, arc or arch architecture stuff, code generation. Link is probably like link time compile stuff. Then air.zig, who knows what that is? Some Darwin POSIX stuff. Intern pool. I'm guessing a pool of interns. Clang value. Value is probably pretty fundamental. And some of this looks interesting. So let's go over to lib and just see what's in lib. In lib we have standard. We should definitely look at standard. We have libc. I don't know if that's worth looking at. And include compiler RT. Maybe runtime or real time. TSAN. I forget what the TSAN is. It's different from address sanitizer, right? Sanitizing tamales. Thread sanitizer. While we're here in the search engine, let's look for Zig metaprogramming. This is just some blog post. Let's see if we can find some source code that looks like metaprogramming. We have some. I guess we have this type info T. So this is, I suppose, using the runtime reflection somehow. All right. So where do we want to start? Let's open up some of the stuff in source, I guess. Module. Air, just because I don't know what air will be. Value, sema, introspect. I think seems to be part of what they're like marketing as the defining features of Zig. Unwind, who knows? Main, I guess we might as well look at. Target, Tracy, and then some Clang stuff and some LLVM stuff. And then we have folders for a bunch of stuff. Should we look at Bitcast? Probably not. Liveness, I guess verify. Package. I'm going to assume that packages is support for downloading and working with packages. We have fetch.zig, which makes me feel like that's probably the case. I don't know if there's anything interesting in Arch. How about ARM? Emit, mirror. Mirror should be something, maybe intermediate representation. But we're not going to look at that. So let's take a look at what we have. I'm trying to sprint through the remaining repos I have left on my backlog. So we may not do a full hour on any of these things. I'm sure Zig deserves a full hour, but kind of is what it is. All right, here's lib standard. I don't think we've really opened any of this stuff yet. We have progress and I guess a ring buffer. I always like to look at ring buffers. Maybe thread. I don't know what target is, but we'll look at target. We have array list, array hash map. I guess let's look at the hash map and the atomic. Actually, not atomic. Should we look at bit set maybe? Maybe? C.zig, debug, dwarf, enums, and some HTTP stuff. I guess let's look at heap and HTTP and maybe one more. I guess zig.zig. All right, let's take a look see. Oh, wait, I think that I opened this directory, this lib include, and I haven't looked at anything here. And I think I'm not going to. This looks like maybe not the most important stuff. Here's compile RT, which is a folder that looks like it has a bunch of implementation stuff for perhaps different architectures and a floor function. So this is divc3.zig. I'm not really sure what divc3 is, but it's something. Based on Annex G of C17 standard. Divc3, we've got some comp time T, whatever that is. I guess at compile time, maybe T is a type. A is some type, I guess the same type. B is the same type. C in and D in, I don't know what in means, but they're also T's. And we're going to return a complex T, maybe a complex number. And we're taking the inputs and declaring variables for them. And so this seems to be a division implementation. Okay, so maybe these aren't implementations for, well, we have ARM. What is ARM? We have ARM and atomics as well. This is ARM specific built-ins for runtime ABI. Okay, so I'm not really sure what this is. Seems to be a bunch of math functions together with some like ARM specific stuff. But we're going to ignore it for now and maybe come back to it if we need to. Here's the compiler folder. We have format, libc, obj copy, resonator, and reduce. Reduce has this walk thing. I guess we'll open walk. And resonator has what? Compile, errors, ICO, lang, lex. So this looks like compiler implementation stuff. So it's good to know where that is, but we will ignore it for now. And then we have hopefully just zig files. And what order do I want to do these in? I guess I'll do them in the order I opened them. There's no rhyme or reason to that. Usually there is. I'm not sure that I want to see module first. How big is module? This is big, 6,300 lines, 1,800 lines, 442. This is almost 40,000 lines. Introspect is 143 lines. Let's look at that. Okay. So we're importing some stuff. These, I presume, would be modules, possibly packages. We're importing standard and built-in. And you're, I guess, defining mem to be mem from standard. I don't know if this is just like an alias or if this is actually, well, there's no import statement. So I guess this is maybe just defining this as a shorthand that we have to write fewer things. And then we're importing compilation.zig, which I'm going to guess is in the same directory. You'll see no directory information here. And then also build options. Build options and built-in and standard don't have .zig. So I'm guessing that the .zig notation means that we're like importing a file, whereas build options might import like a package that somehow the package manager or compiler already knows about. And we've got this test install prefix, which has some base directory, which is of type fs.dir. We got fs from the standard library. And it's returning a question. I assume this syntax means it's returning a question mark compilation.directory. And I'm going to guess the question mark means it's nullable. And we try to open a file here. We might catch an error, some sort of exception. And if we do, I suppose that we try to close the directory and then break whatever this colon thing is, colon zig dir. maybe this releases. I guess we're breaking out of this like stanza. It has a label, kind of like a go-to. But instead of like writing go to the next stanza, we're just breaking out like we would break out of a loop, I think is the idea. Yeah. And then we have more catch stuff. So I'm guessing, okay, so return null. So there we have the null ability. So I think that's what the question mark means. Find zig exe path. So this is just finding out where the path is. I don't know what WASI is. Is that WebAssembly? This function is unsupported on WASI. All right. And then this is just so far a bunch of like looking for various directories where we've installed stuff. I thought this was going to be introspection, as in understanding the types of the source code, but so far it seems to be about looking for binaries and libraries and stuff. Yeah, WebAssembly. Thank you. Get, study, learn op. All right, more looking for directories, and then we have is upter. This is just directory management. Okay, that was not so exciting. How about lib unwind 209? Sure. Then we have this build static lib function, which takes a comp, which is type, I guess, maybe pointer to compilation, and a prog node, which is a progress node, and it returns a build error bang void. I'm not sure that I have a clear guess for what this notation means. I'm going to guess some sort of combination of build error and void. Returning something, if this were build error or void, it seems like it would be just using the nullable notation. So this is perhaps maybe build error is parameterized, and this happens to be a void build error of some kind. But we will presumably see a similar type annotation later. We check if we have LLVM and do some maybe error handling. We get this tracy stuff, which is going to assume is somehow tracing things. We have an arena allocator in this comp.gpa. We saw the GPA stuff. It was some kind of allocator. We're calling compilation config resolve, passing in a block that seems a little bit maybe reminiscent of using JSON as a way to handle structs, which is something we see in languages like maybe Dart, and there's like a kind of element of that maybe to Go as well. And we're configuring this. This seems to be some struct config, and in fact, it's being named config, which makes sense. We have more error handling. I don't know what it means to catch the absolute value of error. Maybe that's kind of like this is the type of a lambda or something. And we've get the root module. We're going to create a module, I guess, in the arena, passing in the cache directory. And the paths are going to be, the root is whatever the root directory is, and then comp zig lib directory, and the root source path is the empty string. So something about setting the root. Here we're doing a bunch of C flag settings. I guess these, I don't know if you can override these, or maybe you need to have these settings if you want to do zig stuff. And then we are going to create this compilation, and presumably it's going to ultimately call LLV clang, essentially, right? And then I don't know what lib unwind is actually doing. What is it unwinding? I don't know. Let's see if we can find the word unwind. Libunwind optionally provides an alternative implementation of the Itanium exception handling ABI. So this is just some library. That's not so fundamentally important. Here's main.zig. This might be important. It's big. And let's scroll through the whole thing. So here, so we can tell a bunch of this is, actually, instead of scrolling through, let's make it real small. So this is like defining arguments for, let's make it slightly bigger than that. Defining arguments for some compile line, these are compile, no, what's the word? Command line arguments. We have this build output type stuff. This looks like just putting data in a struct of some sort that seems to be configuring stuff. It is for debugging, lib unwind. Okay, cool, thank you. Get study learn op. And this just seems to be like a pretty configure main file, which is pretty common for main. Let's see if there's anything that looks like it's a implementation of stuff. Where can we see how, let's use this. We have create module that might be doing stuff. Although I don't know. I'm going to guess that most of this, well, I see some job queue stuff. We have command fetch. I guess fetch is for, we saw fetch when dealing with downloading packages. So I'm going to go back up to full screen. We'll see if there's a main method that we can jump to. So I guess it's not const, oops, const main. Is it int main? We have clang main, LLD main. Yeah, I don't know. Do we get a comment? No comment. How about, I saw some stuff with job queues. So job queues, I guess, is for fetching. We're doing HTTP work. All right, I'm going to guess this is just mainly setting stuff up and doing bookkeeping. I'm going to plow ahead and see if I can find files that are more like fundamental to what Zig is doing differently. Here's verify.zig. And I don't know what this notation means. I don't know if this is like variable assignment, but we have GPA : standard mem allocator. Air is air, liveness is liveness, and so on. And then we have this error that's, I guess, an error of, this is perhaps like an enum of liveness invalid or out of memory. There's presumably are two kinds of, or the two kinds of errors that you can encounter in this file. dinit takes a pointer to verify. I'm guessing this is the pointer syntax. And returns nothing. And it tries to call self live dinit on the GPA thing, which is, I'm going to assume, an allocator like it is in the other files. And then we try to declare this variable, block it, which is set to the whatever happens when you call value iterator on blocks, self.blocks. And while we have blocks left to consume, we get the block. Again, I think this is probably like lambda capture. And then we dinit the block. So whatever the blocks were, presumably blocks of code, we're dinitting them, passing in the allocator. Presumably they were allocated with this allocator, and then this is going to deallocate them or something. And then we were iterating over the blocks. Blocks seems to be some sort of container. And then we're calling dinit on, I guess, probably the container itself. And then we're setting self.start to be undefined. So this is uninitializing whatever self is. I guess the verifier or something. And then we have verify. which takes in a self, which is of type star verify, and returns error bang void. And we call on live clear retaining capacity. Then on blocks, we call clear retaining capacity. And then we try with no catch, I guess, to call verify body, which calls self air get main body. Or not, it doesn't call that, rather. We're passing in that as an argument. And then it seems like we'll look at verify body. I still don't know what air is, but we have this comment. We don't care about self.live now because the loop body was no return. Everything being dead was checked. Sorry, I keep skipping around. I'm trying to use this as a highlighter, but GitHub doesn't like that. And then we have this assert that is, I don't know if it runs only in debug mode or always, but we are asserting that there are no more blocks left. And then we have this live map, which is some auto hash map unmanaged of air index. I guess returning void, maybe? I don't know. Perhaps this is basically a set because it's not mapping into anything. I don't know. So here's verify body. I have a feeling this is going to do real work. Yeah. Okay, so it's of type star verify. And the body is a list of air indexes. And again, we've got this error bang void thing. We set IP to the intern pool. And the tags we look at the air instructions and get the items with the .tag, I guess, label or something along those lines. And then the items with the data label. And for body, I'm guessing this is for each thing in body. Where did body go? Body was passed in. It's an index of instructions. And I guess the thing that the index holds are individual instructions because we have this thing, which again, I assume is lambda capture. Actually, let's just verify this. Zig lambda capture. How much is Zig syntax? Nope. Okay. Well, let's ask the AI since it doesn't seem to be showing up easily on search. Tell me about this snippet of Zig. One, what is the asterisk? Okay, so asterisk is a pointer and it's part of for each loop construct. Okay. All right, so this is all right, at any rate, this is defining, I think based on other languages, this is basically you pass to for each. Spiritually, what you do is you pass it a function that takes in an argument. It's basically an unnamed function, a lambda function. It takes in some argument, and this is the syntax for like what that argument is to be called for the code block. And at any rate, so for each instruction in this body thing, we check if it's unused according to liveness, which is perhaps something about some kind of maybe something similar to a garbage collector walk. But if we are unused and we don't have to lower the instruction, whatever the intern pool is, it says this instruction will not be lowered and should be ignored. Then we continue. And then we've got a switch statement on the tags. Tag seems to be some sort of dictionary. it's definitely some sort of container, and we look up in that container using this int from enum, some sort of casting operation. We pass in the instruction, which seems to be an enum, and we get some kind of int back. And I don't know what no operands means, but we have things like arg, alloc, inferred alloc, fence, etc. And if it's any of these, we call, I guess is what the syntax means. We call verify inst operands, passing in none. So I guess these are like statements that don't have an that you don't pass any arguments. Like breakpoint doesn't really take an argument. And then we have unary things. So not of what you need to pass something to not. You need to load something particular. So these are like instructions that take an argument, and somehow you get the argument. You call try op by looking up in the data container, presumably kind of like a hash map. And whatever tie op is obviously operator, or operand rather, and tie is whatever the prefix to operand is in the data, the data struct. And then you call verify inst operands on this. So I'm guessing that verify inst operands is basically like kind of like type checking, that the things that you're passing are like, if you pass not, it should be something that more or less evaluates to a bool. It should be some sort of predicate statement. Otherwise, not doesn't make sense. So I think that this is maybe doing something similar to type checking, but we'll take a look at it. What do I mean? Oh, maybe capture is not the right word, but I think lambda capture is something different now that I mention it. So let's look that up. But I mean, it's just the argument to an anonymous function. So capture, I think, is where you closure, an unnamed function object capable of capturing variables in scope. So capture is where you, well, maybe it is the same thing. What does it look like in C++? You have this, do you have a really simple example? Basically, like when you're defining an anonymous function, you're like giving to it, binding up to it like a piece of information, a variable that's in scope where you're defining the function. See if we can find what does the word capture mean in the context of lambdas? It's capturing an outside variable. A lambda is a syntax for creating a class. Capturing a variable means that that variable is passed to the constructor of that class. Is that true? What language are we in? How do you tell which... this looks like C++. Yeah, C++11. Okay. I don't know if that's true that a lambda is a class, but a lambda can specify whether it's passed by reference or by value. So you just need some, or in like Python, you need some way of saying what the variable is. And that's what I really meant. I didn't mean that we're capturing something from the environment. I meant it was the name of the variable that was going to be in the lambda expression. What is my take on Windows recall? I have no idea what Windows recall is. I think that's the is that the thing that's like always watching you? It's like always screenshotting you. I think it's I wouldn't use it, but I thought this was before I heard about Windows recall, I saw a bunch of projects on Hacker News of people making this basically for their Macs. And I don't know if this was something that happened first on Mac or if this is something that happened first on Windows. Let's see if this returns anything. I don't know. But yeah, I mean, I don't want, I wouldn't want somebody to take a screenshot of everything and then build a database on it. So personally, I don't use Windows. I don't think that I wouldn't recommend I wouldn't recommend it. But that's about all I know. All right, so we're back to verify. So these, I guess, are more operations, and we're verifying these operands. So let's look at verify inst operands. How do we know when something is a function? Let's see if this will give us. No. Here we go. Function. Oops. All right, function verify inst operands. So we're going to loop over the operands. I don't know what the 0 dot dot is. Maybe that's a way of grabbing an index. And here's the for each loop stuff, operand index. I guess, yes. So this is some index. So operand dies. I don't know what that means. And if what? Operand dies. I have no idea. But we get whatever operand dies is. I don't know if this is dies in the sense of like it stops working, but we call verify operand on inst operand in dies. And then we try to self verify inst. And we can look at self verify inst. Verify inst checks if the instruction is unused. And if it is, we assert that that live doesn't contain the instruction. I guess I didn't realize that live and liveness are separate until now that I'm seeing them right next to each other. And then if the instruction is not unused, so it is used, we try to put no clobber, passing in the allocator in the instruction. And I don't know what that means. I guess we're trying to put it somewhere, I guess in live, no clobber, presumably don't overwrite something else. But what, I don't know. And who knows? So let's look up this dead thing or dies thing. It's presumably in liveness. So let's go to liveness. I must have it somewhere, but maybe I'll just do search. Here's operand dies. So we pass in an air inst index. And we get from the instruction, we get an int, and we multiply by BPI. Bits per index. We divide by the bit size of usize. That gives us the usize index. So maybe this is some sort of bitmap. And then we make this mask. I'm doing some sort of masking stuff with log to int. Yes, this feels like we're looking something up in a bit mask because we're calling log, I assume, what that's up to, and whatever BPI is, and handling off by one errors. And then we're returning L, which is liveness, tomb bits at the usize index ANDed with the mask and checking that it's zero, not zero. And I'm guessing tomb is maybe tombstone. Oh wait, I was reading the wrong function, wasn't I? Well, that's fine. But we're doing a similar thing. So is unused is the thing that we just looked at, and then operand dies is, how's that different? We're getting an operand, And where's the first place we use it? We use it here in the calculation of the mask. We're adding the operand to the mask, and again calling tune bits. So let's look at tune bits. We're in liveness, right? So we have this analysis struct that has tune bits. We have get tune bits, some code gen stuff, and a call to truncate them. This can't be all the things. Oh, 3 more. Okay, so I forgot GitHub does this thing. 20 more matches. So this is no better than being in the previous screen. All right, GitHub. This is the best you can do. All right, so let's go back to liveness. And back to tune bits. Oh, here we go. So this array is split into sets of 4 bits per AIR instruction. AIR, something intermediate representation maybe? Is whether so the MSB, most significant bit, is whether the instruction is unreferenced. The least significant bit is the first operand, and so on up to 3 operands. A set bit means the operand dies after this instruction. Okay. So for each operand, there's a bit in this map, tune bits, that tells you whether the operand dies. What does that mean? Is that like an ownership thing? I don't know what it means to die. Presumably it means you can't use it in some sense. Instructions which need more data to track liveness have special handling via the special table. So let's look up Zig tune bits and see if there's any. No? How about Zig liveness? Let's see if the in-depth overview tells us something. Tomb liveness. Hello. Hello, Jose. All right, we're going to ask Gemini. Tell me about tune bits and operands dying in Zig. So they are special flags associated with memory locations in Zig. They indicate whether the data at that location is still valid or has been tombstoned. Okay, so when it just goes out of scope, this signals to the compiler that the memory can be potentially reused for other purposes. They help prevent dangling pointers. Operand death is a concept related to how expressions are evaluated in Zig. An operand is a value used in an expression. In Zig, when an operand is no longer needed for the evaluation of the expression, it's considered dead. When an operand dies, Zig might automatically deallocate the memory associated with it. Okay. They say this, Gemini claims this is the official documentation, but it's hosted on Reddit. This seems pretty good. Maybe I'll bookmark this. And so how does this compare to other approaches of handling memory management? I'm looking at the Zig source code. It's telling me a bunch of stuff, but none of it is really useful yet. Okay, so at any rate, this is related to how Zig manages memory. It keeps track of when when something is used up using this. It's an array. I'll consider it to be basically a bitmap, or rather, it's an array of usize, I think. Four sets of bit per error instruction. Oh, I guess there's. I think each entry is one of these tombstone things. So I think each entry in this tomb bits thing array is a bitmap. Is how I'm thinking of it. Okay, so that's part of the Zig stuff. We're still in liveness. I guess let's take a quick look at liveness. Liveness pass data. Each analysis pass may wish to pass data through calls. A pointer to a liveness pass data pass stored on the stack is passed through calls to analyze inst. So you've got this function live pass data. You pass it some liveness pass thing, and it, I guess, returns a type. And we're switching on pass. We call D init, and then I guess if the pass is the main analysis, then I don't know what it means to return a type. I'm wondering if this is basically like any type. So I think if we're in the main analysis pass, then we return a struct that has a bunch of stuff. One is a bunch of block scopes, which is some hash map of every block currently under analysis. And we also return a set of instructions currently alive in the control flow branch, index for data, etc. Okay. We have operand categories. And these include things like tombstoning, whether the instruction dies at the operand dies at the instruction, whether we can mutate memory, whether the operand lives on and this instruction is no return, and whether this instruction is too complicated for analysis. No information is available. Okay. And then what are these? These seem to be more instructions. So seems to be some switch statement. And if we are in dot fence, we're going to return dot right, dot not, etc., etc. Oh, no. Maybe this is the next line in this switch statement. Oh, no. Okay, so dot fence only returns dot right. And then these are, if you have any one of these, then you return something else. Something with error. So let's find error. How about we just do a search for error.zig. Analyzed intermediate representation. Okay, so I got the IR part, right? So A is analyzed. So I guess this is an intermediate representation that is somehow partially processed. And what do we have? We have so the tags seems to be an enum, maybe backed by a U8. And we have what? The first n instructions in the main block must be one arg instruction per function parameter. Blah, blah, blah. Then we have add for float or integer addition, add safe, add optimized, add wrap. I'm not really sure what these tags are really doing. So mul wrap is 2's complement wrapping integer multiplication. Both operands are guaranteed to be the same type, and the result type is the same as both operands. Uses the bin op field. So somehow, I guess it has the intermediate representation, and tag is kind of an enum that's keeping track of stuff potentially that the compiler needs to know to do things like type analysis. So for example, the one we just saw, that if you add two numbers together, you should get back a number of the same type. At least that's how I'm going to think about it. I don't know if that's literally what's going on. This I think is just more tags. A ref enum, either a reference to a value stored in the intern pool or a reference to an error instruction. The most significant bit of the value is a tag bit. The bit is a 1 if the value represents an instruction index, and 0 if it represents an intern pool index. Whatever that means. We have vector compare. Okay, let's find out what intern pool is. A reference to a ZIR instruction or to an intern pool. I don't think we've seen ZIR yet. So we have some intern pool.zig file. Any chance we've opened it? I'm not going to get to most of these. Let's see if we can find it here. It's not there. What if we just do? You can't find this file. GitHub. Okay, let's look in source. There we go. All interned objects have both a value and a type. The data structure is self-contained with the following exceptions. Module.namespace has a pointer to module.file. So I think that I'm supposed to know what interning is. Maybe compilers. String interning. String interning is a method for storing only one copy of each distinct string value, which must be immutable. Are there other types of interning? Let's try computer science. It might be the same thing. It might be having only one copy. We're using objects of equal value on demand instead of creating new objects. This creational pattern is frequently used for numbers and strings in different programming languages. In Python, even primitive types such as integer numbers or objects to avoid the overhead of constructing a large number of integer objects, these objects get reused through interning. Okay, so it's some object reuse, and so they keep a pool of interned objects. Here's compile time garbage collection. Remember Andrew Kelly mentioning that the Zig compiler performs comp time garbage collection. Okay. So whatever, don't know why I was looking at the source of this page. Okay, so intern pool is going to be some pool of like reused objects. We're storing some dependency information. We have this tracked inst, which is some extern struct, and we've got a function to resolve that seems to be looking up stuff in some sort of table, and so on. Okay. I think this is all I'm going to look at Zig for now. As I've been mentioning, I'm trying to plow through my backlog. So there's a lot more we could look at for Zig, as with all of these projects, but I'm going to time box these and just kind of chug along. And then if there's a project that we really want to revisit, we can always do that.